Welcome all of you. Myself, Professor Rajendra Gori from Civil Engineering Department, CSMSS College of Polytechnic, Aurangabad. In previous lecture, we will see the moment of inertia and how to find the moment of inertia of a standard section above the center of gravity, horizontal and vertical axes. In this lecture, we will discuss the parallel and perpendicular axis theorem and application of it. So first, parallel axis theorem statement. It states that the moment of inertia of a plane section about any axis parallel to the centroidal axis is equal to the moment of inertia of a section about centroidal axis plus the product of area of a section and the square of a distance between two axes. Consider an arbitrary area having cross-sectional area A and a horizontal XX axis is passing through CG of a section and a parallel axis AB at a distance h from the centroidal axis. So moment of inertia at parallel AB axis is equal to the moment of inertia of a centroidal axis plus area of a section into square of distance between these two axes. So the mathematical expression for the parallel axis theorem is IAB is equal to IG plus AH square, where IAB is equal to moment of inertia about axis AB, which is parallel to XX axis. Ig or Ixx is equal to moment of inertia about centroidal axis. A is area of cross section and H is distance between two axes, that is AB and XX axis. Perpendicular axis theorem. It states that if Ixx and Iyy are the moments of inertia of a plane section about the two mutually perpendicular axes meeting at O, then the moment of inertia Izz about the third axis ZZ perpendicular to the plane and passing through the intersection of XX and YY is equal to the addition of moment of inertia about XX and YY axes. Means what? Consider a solid circular section having horizontal XX axis and YY axis passing through its CG, and the third Z axis is perpendicular to the plane of a section and intersecting at the intersection at the mutually two perpendicular axes. So the mathematical expression for the perpendicular axis theorem is Izz is equal to summation of Ixx plus Iyy, means moment of inertia about XX axis and moment of inertia about YY axis. If Ixx and Iyy are the moment of inertia of a plane section about the two mutually perpendicular axes, then the moment of inertia Izz about the third axis ZZ perpendicular to the plane and passing through the intersection of Ixx and Iyy is called as polar moment of inertia. So Izz is also called as polar moment of inertia IP. So polar moment of inertia for solid circular shaft of diameter d, Izz or IP is equal to, by using perpendicular axis theorem, Ixx plus Iyy. So for circular section, Ixx is equal to pi by 64 into d to the power 4. This standard formula for moment of inertia about Cg for circular sections. So polar moment of inertia is equal to Ixx plus Iyy. So Ip is equal to pi by 64 d to the power 4 plus pi by 64 d to the power. So Ip, polar moment of inertia for solid circular shaft, is pi by 32 into d to the power 4. For hollow circular shaft having external diameter d and internal diameter small d, then polar moment of inertia is equal to Ixx plus Iyy. For hollow circular section, moment of inertia about xx and yy axis is pi by 64 into capital D to the power 4 minus small d to the power 4. So Ip is equal to pi by 64 capital D to the power 4 minus small d to the power 4 plus pi by 64 capital D to the power 4 minus small d to the power 4. So polar moment of inertia for hollow circular shaft is pi by 32 into capital D to the power 4 minus small d to the power 4. Numericals on parallel axis theorem. First problem. Determine the moment of inertia of a rectangular section 100 mm wide and 200 mm deep about base parallel to the 100 mm side. So in this problem we have to find out the moment of inertia about the base, that is AB. In figure you can see we have to find the moment of inertia about AB line. So in standard problems in previous lecture we have to find the moment of inertia about the centroidal axes, that is Ixx and Iyy. By using this parallel axis theorem we have to find the moment of inertia about some distance from the centroidal axes. So given data, b is equal to 100 mm width and depth is equal to 200 mm. Ixx and Iyy is the centroidal axis passing through CG, and AB is parallel axis at which we have to find the moment of inertia. So to find the moment of inertia about the base, since the centroidal axis xx axis and base AB are parallel, we can use the parallel axis theorem to find the moment of inertia about base, that is IAB. So by using parallel axis theorem, IAB is equal to Ig plus A into H square. IAB is moment of inertia about AB axis which is parallel to XX. Ig is moment of inertia about horizontal centroidal axis. A is area of sections and H is distance between two axes, that is AB and XX. So for rectangular sections, Ig is equal to B into D cube by 12. This is standard formula for rectangular sections. Moment of inertia about centroidal axis. So B is 100 into depth is 200 cube by 12. So Ig is equal to 66.667 into 10 to the power 6 mm power 4. Area B into D. So B is 100 into 200. So 20 into 10 to the power 3 mm square. H is for rectangular sections, distance of CG from base is D by 2. So 200 by 2 is equal to 100 mm. Now moment of inertia about AB is Ig plus AH square. Here we can see we have to choose Ig, moment of inertia about centroidal axis XX axis, because AB line or AB axis is parallel to the XX axis. When AB or parallel axis is parallel to YY, then we have use the centroidal axis as YY. But in this case, AB line is parallel to XX axis, so Ig is XX. 66.667 into 10 to the power 6 plus 20 into 10 to the power 3 into 100 square. So moment of inertia about AB is 266.667 into 10 to the power 6 mm power 4. Next problem. Determine the moment of inertia for rectangular sections 100 mm wide and 200 mm deep about vertical axis parallel to the 200 mm side. So in this figure, B is 100 mm, similar as previous problem. D is 200 mm. But the main difference in This problem is, in previous problem we have to find the moment of inertia about the base, and in this problem we have to find out the moment of inertia about vertical axis parallel to the 200 mm side, that is AB. So in this case Ig is Iyy because of the parallel AB axis is parallel to the YY centroidal axis. So we can use the Iyy in parallel axis theorem. So B is 100 mm, D is 200 mm. IAB is equal to Ig plus AH square. So IAB is moment of inertia about AB, which is parallel to YY axis. Ig is Iyy moment of inertia about vertical centroidal axis. A is cross sectional area and H is distance between two axes, that is AB and YY. So Ig is equal to Iyy is equal to dB cube by 12 for rectangular sections. This is standard formula for moment of inertia about YY axis. So D is 200 into B is 100 cube by 12. So 16.667 into 10 to the power 6 mm power 4. Cross sectional area 100 into 200. So 20 into 10 to the power 3. And H is equal to B by 2. So 100 by 2 is 50 mm. Putting these values in parallel axis expression, IAB is equal to Ig plus AH square. Ig is 16.667 into 10 to the power 6 plus 20 into 10 to the power 3 into 50 square. So moment of inertia about AB is 66.667 into 10 to the power 6 mm power 4. So remaining problems we can discuss in next lecture. Okay, thank you.